ELP Project, Working of a Crystal Radio, made by Rajat Kolesha. How a crystal radio works. This project intends to explain the internal working of a radio. How can we simply play a song just by turning a knob, sitting in a chair, what all processes go on behind the scenes, etc. The mechanism. A radio consists of several parts like the antenna, the tuner, the detector, the amplifier, and the speaker. Circuit diagram for crystal radio. The crystal radio consists of the antenna, an inductor, a capacitor, a diode modulator, and a speaker. Step 1. Receiving the signal. A transmitter emits the signal which contains all the information that we need to hear. The signal travels through the air and is received by the antenna. This signal, consisting of EM waves, causes the electrons to wiggle in their position, resulting in an electric signal generation in the antenna, which is received by the radio. Step 2. Tuning into the right signal. The antenna receives all the signals in the surrounding, but we only require a single signal to be listened to. That's what this oscillator circuit does. From among all the signals that are received, only the one with the frequency matching with the resonant frequency of the LC oscillator circuit will get amplified by the circuit. All other frequencies are going to be ignored. Radio knob. When we turn in the radio knob, we are adjusting the frequency that our tuner would tune into. When we turn the knob, we are altering the inductance or the capacitance of the oscillator circuit. We know that it is possible by increasing the space between the capacitor plates or increasing the number of loops in the inductor, or by any other means we alter the inductor or the capacitor or both, thereby changing the frequency of the tuner circuit and tuning into our favorite station. Diode component connected in the circuit acts as a demodulator, clipping off the signal from the one side, resulting in an output direct current that does not have an amplitude averaged out to zero, but varying with the audio signal. Crystal radio had no amplifying components to increase the loudness of the radio signal. The sound power produced by the earphone came solely from the radio waves of the radio station being received, intercepted by the antenna. Therefore, the sensitivity of the detector was a major factor determining the sensitivity and reception range of the receiver, motivating much research into finding sensitive detectors. In addition to its main use in crystal radios, crystal detectors were also used as radio wave detectors in other scientific experiments in which the DC output current of the detector was registered by a sensitive galvanometer, and in test instruments such as wave meter used to calibrate the frequency of the radio transmitters. The radio devices that we used in our daily life in our cars and homes are quite advanced compared to the radio devices described in this presentation, but these radio devices that we use in our daily life came into being due to successive development from simple structures like crystal radios. References. Thank you.